Well, let's start the webinar.
Assalamu alaikum. I am Tuba Qureshi, host of today's webinar. Guests and learners, warm welcome to our webinar, Hands-on Implementation of Machine Learning with Python, organized by Quest Innovative Study Circle with collaboration of IEEE IES Node Jamshoro. Today we begin very informative and engaging session in the world of AI technology that is transforming industries, business, even all the sectors worldwide. With our esteemed speaker, Sir Ehtisham Raza, AI and machine learning engineer with 3 years of working experience in FI Tech, we aim to delve this webinar in the practical aspects of machine learning. So guys, get ready to delve this webinar into the world of data-driven insights and machine learning algorithms. So I would request Sir Ehtisham Raza, please start the session.
Assalamu alaikum guys, everyone. How are you all guys? I'm Ehtisham Raza. I'm AIML engineer working in a fintech from last 3+ years where I'm useful for solving machine learning problems using different techniques and technology. So today we are going to talk about the machine learning implementation with Python. In our last webinar, we talk about the future trends and the industrial trends of the machine learning. Now we are going to get hands on how we can use machine learning to solve our industrial problems. So today we are going to solve a very interesting problem. So let's start our webinar. So our today's agenda is introduction to machine learning. We're going to talk about the introduction to machine learning, types of machine learning, algorithms of machine learning, and implementation of ML algorithms. We are not going to spend a lot of time in our first 3 points. We are mainly going towards to the implementation of machine learning algorithm, but we'll just go a little bit walk through on these things. So this is all about my introduction. I'm AI/ML engineer working in a fintech, having 3+ years of experience and solving financial problems using artificial intelligence and machine learning. You guys can add me on LinkedIn, Medium, and there's a distortion. There is a very high distortion. Tuva, can you please check what kind of distortion it is?
Yes, sir.
There is a distortion in the background. Just now it's very clear. Okay, so you guys can also add me on LinkedIn and you can also follow me on Medium so you can have my updated blogs and my articles on the Medium. So what is machine learning? Let's go and see. Machine learning, we have already seen. I'm just going to walk through. Machine learning basically a set of problems program which you go to and feed your machine learning algorithm, and your algorithm learn from those instructions and those data how to predict from the real data set. So machine learning is basically instead of writing a code, you just simply feed your data and set of instruction to your algorithm, and your algorithm learn from that data and also from your instruction and predict the on the real world on the unseen data. So machine learning has a different phase. In the first phase, you acquire the data set, you retrieve the data set from different, if let's say if you are going to predict is this person is going to buy my product or not, maybe you can acquire different kind of data set. If you are working this product this if you're solving a problem of healthcare, you will go and acquire the data set from the healthcare. If we are solving a problem of finance, you're going to acquire that data. So according to the scope of your business problem, you are going to acquire that data set. So data assets is basically a fuel of your machine learning project. If you don't have a fuel, you cannot run a car. So similarly, if you have a data, you can just perform your machine learning algorithm, you can perform your prediction, you can go whatever you want to do with your machine learning algorithm. But if you don't have a data, you cannot perform anything. So first task is to retrieve the data set. Once you have the data set, maybe you will not have that data set into your desired conditions. So you may go ahead and check the data set is in a desired condition or not. Maybe some pre-processing is required, some noisy data, some kind of outlet, some kind of missing values is available in your data set. So you will go and find out what kind of issues are arising in my this data set, and you will fix that issues. So once you fix those issues, you will go ahead, you will pass this data set to your machine learning model. What is machine learning model? Machine learning model is basically a machine learning algorithm which learns from your data set. You pass lot of number of rows, many big number of data set, and your machine learning algorithm learn from that data set. After learning, it basically perform a prediction, and you calculate the performance of your machine learning model. If your machine learning model is performing really well, then you simply put into the deployment. If your machine learning model is not going very well, you will just simply go back and you will perform all the pre-processing step. Maybe you have to check your data is right or not. Maybe you're passing a right, not right, the algorithm is not sufficient for your this kind of this. So you will reiterate till satisfactory model performance. So there is a iterative process. So once you don't have the required desired desired accuracy, you will go back and keep checking until you don't get your desired accuracy. So this is a machine learning life cycle where you feed your data, you perform the pre-processing. Once you perform the pre-processing, you train your ML algorithm. Once you train your ML algorithm, you evaluate, and after evaluation, if you check if the evaluation is really well, if your desired results are coming up from your ML model, you put into the production. Otherwise, you just simply go back and reiterate the process. Types of machine learning, I'm not going in very well detail. I'm just going to give you three. There are three types of machine learning. Supervised, in which you have a data set and you also have the labels of your data set. In unsupervised, you pass the data set without the labels. Your machine learning algorithm has to find out the patterns from that data set and find out what kind of functionality can be done on this. Reinforcement learning, basically this kind of learning is involved in robotics, gaming. Just like if you have played a PUBG, so your PUBG is basically a built on the reinforcement learning, in which your game is learning from you what kind of problems you are, what kind of scenes, what kind of issues you are facing in a game, what kind of scenarios you are facing in a game. The next scenario will be also right there. So that game is related to the reinforcement learning. So these are the three main types. There are also another types, but three main types are generally talked about the machine learning. So this is in which machine learning we have a, we pass the image, also we tell them this is a duck. But in unsupervised, we pass the image, we don't tell him it is a duck, it is what is this. So your machine learning algorithm automatically finds out, is it, if this is a duck, the features of the duck is look like that, the peak of the duck is like that, the duck has this number of legs, the duck has this texture, skin color, this is a duck, is this is a rabbit, is this a snail, if this is a pigeon, whatever it is, it finds out based on his understanding. In reinforcement learning, you just simply pass the input image. Your algorithm will make mistakes. After taking a mistake, it will learn from its mistakes, and the more the mistakes the algorithm is doing, the more it is getting more intelligent. So your agent goes and interact with the environment. After interacting, it gets some experience, so that experience is used to make the predictions for the environment. So this is a reinforcement learning, unsupervised and supervised learning phases. First phase is basically you train your machine learning algorithm. You pass the data set and you train your machine learning algorithm. So your machine learning algorithm get trained on the training data set. And once your algorithm is trained, you ask him, hey, look like this, these are the features. So when you come any this kind of scenario, so maybe the output is this. So once you train this, you just simply perform the validation. A validation data to find out the patterns, match the predicted output and the actual output. So once you train the model, you go for the validation phase. In the validation phase, you check is my model is has learned really well or not. So once you perform the validation, is the find out the non last step is to test your model. You just simply pass the unseen data to your machine learning model and you just test the performance of your model, how your model is performing on the unseen data set. So because if your unseen data is if your model is working well on the unseen data, so you can say yes, my model has learned really well. So these are the things. So we in our machine learning we have different type of algorithms. If we go about deep learning, we have deep Boltzmann machine, deep leaf networks, stacked autoencoders. If we talk about the ensemble we have different kind of algorithm: random forest, gradient boosting machine, bootstrap aggregation, ada boost, stack generalization, gradient boosting trees, radial basis neural network. If you go about the neural network, we have perceptron, back propagation, hope field network. If we go about the regularization, we have different regularization techniques: rich regression, least, absolute, shrinkage, and selection operator, elastic net, least angle regression. If we talk about the regression algorithm, we have the stepwise regression, we have logistic regression, we have k nearest neighbor regression. So we have different kind of algorithm. These are all the algorithms which are available in the machine learning libraries you can use to perform your task. So choice of algorithm depend on your use case. Let's say if I have to pick a classification algorithm, it will I will pick classification algorithm because my task is related to classification. I am going to perform a classification task. Why I am picking? Because I need to perform a classification task. I am going to pick a regression algorithm. The reason is I am going to perform a regression. So the choice of algorithm, there are a lot of algorithms available. The choice depends on you what kind of algorithms. If you are picking a regression algorithm, there are also a list of multiple algorithms. So it depends on your data set. It depends on your expectations from your data set. It depends on your expectation of your business need. So the choice of algorithm depends on your dimensionality reduction. If you're going to pick a dimensionality reduction, so it means you have a data has a very complex patterns. You have to trying to find out how you can minimize the patterns, how you can how you can squeeze your data, and how you can minimize your data. So your model will be not taking too much complexity, so your model will be having complex data. So all this depends on your use case. What kind of problem you are going to use case you have to identify. So in our today's session, we are going to implement different classification algorithms. We are going to perform logistic regression. We are going to perform SVM. We are going to implement our decision tree. We are going to perform KNN. So we are going to see how these algorithms work. We will compare the accuracies of the algorithms and also see the results. So choice of the right algorithm depends on you and also your business case. If you are performing some kind of computer vision task, so your machine learning algorithm cannot work in that. So maybe you will go for the convolution neural network. If you are going to perform any kind of text summarization, sentiment analysis, maybe convolution neural network will be not a good choice. Maybe you will go for the recurrent neural network. So it all depends on your use case. So but this is the wholesome picture of the all the algorithms of the machine learning which you can adopt to perform your task. So this is all the picture of the machine learning algorithms which you can use to perform. So what kind of algorithms we are going to perform? We are going to perform k-nearest neighbor, logistic regression, support vector machine decision tree. So without wasting any time, let's jump into our machine learning implementation and let's see what we can do. So before going at, let me guys show you the data set. Let me give you a walkthrough about the data set. So this is a data set basically from a banking sector. This bank do a loan, they give a loan to their customers for 15 days, 7 days, and 30 days. They give loan, they also have to recover. So they have a different kind of customer. They have customers from different category. We have different information. We have the loan status. Is the loan is paid back or not? What is the principal amount we lended to this person? What was the time duration we gave him? It was a 30 days, it was a 15 days, it was a 7 days. What date this loan was dispersed, means at what day this loan was given to that customer, and when the loan is due. What was the age of the customer who took a loan from us, and what's the education of that customer, and what's the gender of that customer. So we have all these parameters, and we are going to predict based on this person, is this person is going to give back loan or not. So we have a paid off and we have a collection. Collection means still we have to collect a loan from him. So we are going to predict, is this person, if we come a person from a college and he's a male and his age is this and he's taking a loan of $1,000 of 1,000 rupees, and for the 30 days he's going to pay back us loan or not. So we are going to predict we need to give him a loan or not based on his profile. If he's belonging from high school or below, thus he is a right person to give him a loan or not. Maybe this task, this analysis can be done by our person who is giving a loan, but he is facing a lot of application daily time. He has a lot of application and he has to entertain each application and he has to check each profile of each person. So he don't have a time and he can be biased. So to prevent this issue, we have going to create our machine learning algorithm which can go over through the profile of a person. This is our data set. We are going to check, is this person is a right person to give him a loan or not. He can pay back loan to us or not. So he is going to default or not. So we are going to take this status and we are going to first perform a it is, what is your data saying to you. and then we'll go ahead and see is there any kind of pre-processing required in our data set or not. Once we done our pre-processing, then we'll move towards the implementing the machine learning algorithm. So let's go and start our implementation. So I am just loading the necessary libraries, as you guys know, NumPy, Matplotlib, Pandas, sklearn for the machine learning algorithm, Pandas to read the data set, NumPy for the numerical computation, Matplotlib is to create the visualization which you see in the screen. All this because of the visualization, because of the Matplotlib. So I'm just reading the data set. df.hat is just printing the first 5 rows of the data set. I'm just checking the shape of my data set. My data set has total 346 rows and 10 columns. I have a due date which is not in really a date format. So first I'm going to convert this date into a due date and also my effective date, so I can make sure my data is in a right format. Data visualization and data pre-processing, I'm going to check what is the distribution of my target variable. So my target variable is loan status, is going to pay back loan or not. So this is what I am going to predict. So this is a classification problem. Either he will pay back or not pay back. So this is my two outcomes. So I am just checking my distribution of my target variable. So most of the people have paid back, but 86 people have not paid back yet. So my data is not distributed normally. My data is imbalanced. So we're going to see how we can fix this, how we can handle this kind of data. Because if you have an imbalanced data set, maybe your algorithm is learning from the imbalanced data set. Your algorithm can also make an imbalanced prediction. So we're going to see how we can conquer this issue. So 260 people have paid off the loan while 86 people have still into the collection. We still have to collect the a loan of 86 people. So based on this, we're going to predict what kind of people make an issue in collection. So we are going to perform our analysis. So let's go and see our visualization. So we have created our first visualization based on the principal amount and the gender and paid off and collection. If you see this, there are two graphs. First is for the male and second is for the female. And on the x-axis there are their principal values. What kind of people take loan are highly chances of not yet paid back, and what kind of people do pay back. So paid off is in a red color, means the people have already paid back. Blue is the collection, means they still we have to collect from these people. So most of the collection is has to be done from the male side. The females has very less amount of collection to be done. So most of the females have already paid. But if you see this, it seems like equal distribution. The same number of people have paid back, same number of people have not paid back. So means, but if you take about, if you see this graph, most of the females have already paid back, but most of the but very less have not yet paid back. Maybe they will pay back. And this in this the loan for principal for 800, they have also paid back. So there is very less number of people from the females who has not yet paid back the loan. So it means most of the collections are required to be done at male side. Okay, based on the age size, what kind of people are often not tend to pay back. So if you see this, we have created on the x-axis the age, and on the y-axis we have the paid back or not. Red is for the yet pay, yes collected, and still we have a payback. So for most of the gender of male, starting from this age, from I think so from 22 to 30, they have not paid back. But if we talk about the females, most of the females had paid back the loans. So this is what we are observing. So by performing the exploratory data analysis, we can understand about our data set, what data is saying to us. So we can think, we can talk with our data set. So we have seen, okay, if we have a gender from 22 to 30, maybe the age group from 32 to 30, and the gender is male, maybe the chances of not paying back the loan is high. And if you go as you go up, the age is increasing, people are paying back the loan. So it may be younger people are not ready to pay back the loan easily. Feature selection, what is a feature selection? Let me explain you one thing first. So when you take your machine your data, it's not necessary your all data is useful for you, and it is also necessary the data is in a raw, it's still not useful for you. Maybe you have to we have to fight with your data set to find out some useful insight from your data set. So that's why we apply the feature selection. Feature selection basically it is a process in which you find out and you see how you can extract the meaningful information, how you can extract some information, some insight what kind of feature you can select and which kind of feature you can remove from your data set. It's not all necessary your data always clean. It's going to give you a useful insight. Sometimes you perform additional calculation on your data set to get the meaningful information. Sometimes you delete your data set because your data is containing a lot of unnecessary information. So feature selection is basically, and feature extraction is a task in which you find out how you can eliminate this kind of issue and you get the as much result from your data set. So we have created a bar chart, another column bar chart for the males and females over the day of week. So we have extracted the day of week from 0 to 6. 0 is for the Sunday. So if you see this, most of the people who take loan on the we have created on the effective date. So means at that day the loan was given to them. So most of the people who take loan on the Sunday are highly chances to pay back, and most of the people who take loan on the Saturdays and we observe for the females. So this is we can observe, okay, so if you do a lending to on your weekends, maybe your chances of recovery will be less. So you have to be very sure you're lending on which day. So you have to check. So this kind of analysis is only possible if you fight with our data set, if you dig into our data set, if you try to torture with our data set, so your data will confess anything. So if you want your data should confess anything, you have to torture your data set. So you have to play around with your data sets so you can extract. So what I did, I have the date, so I can extract the day of week. So in Python we have a date function which can extract the day of week, which day of week it is. So 0 means it is a Sunday, so it told me for 0 the most of the people are likely to pay back. So that is only possible if I know this kind of technique, if I only struggle with my data set. Let's look the months people get loan. So we have from 8, 9, 10, 11, 12. So this data is from this range only. So the people who mostly take uh, the chances, the high possibility that people pay off loan in the 19th, 9th and 10th or in the 11th month. So most of the people are likely to pay back their loan on this. Those people who take loan on this month and they are likely to pay back this one. So this is only possible because I have the functionality. I know I can extract the month number from my due date. My due date is my month is just my due date is just a date. I can extract day, year from month from this date. So if I know this kind of techniques, I can easily work around with. So I know, okay, so people likely to pay back on these kind of months. So as of the observation shows that the people who get loan at the end of the week don't pay if off. So as we have observed in the top, so those people who likely to take the loan at the end of the week, they don't likely. So we are going to perform the binary feature binarization. What is the feature binarization? So we are just basically going to create a new column weekend. We are just going to check if our day is greater than 3. So we are going to 1, and otherwise we are going to make it 0. So we are going to create a new column if the day is greater, day of week is greater than 3. So it means the weekend is going to be start. And if day is less than 3, so it's just 0. So it means Z1 means this is a weekend. This loan was dispersed, this loan was given him to be on a weekend. Convert the categorical features to a numerical. So now why we need to convert our categorical features to numerical features? Because our machine learning algorithms are not capable of understanding the textual data set. We have to parse this data set to a numerical data set. We have to convert this data set to a numerical data set. So what we are going to do, we are going to basically parse this gender. We are going to make a new column, a gender, in which we are going to check if a person is a male, we are going to make it 0, and person is a female, we are going to make it 1. So your algorithm will automatically start if 1 it is a female, if 0 it is a male. So as you passing the female and female, your model may be not as a capability to digest this data set. So you have to eliminate this issue from this data set so you can have the maximum understanding of your algorithm. So we have a due date and we have an effective date. We can calculate the deadline in how many days the deadline of this loan is. So if you calculate the deadline, we have a due date minus effective date. So I'm making a calculation. Due date minus effective date is going to be my new column is going to be a deadline in which I am calculating how many, after how many days my deadline is. So it is telling me my deadline is 29 days of this loan, it is in 14 days. So whatever the days it is telling me, but still I don't need this days, I just need a number. So I'm going to say df deadline dot dt dot days. So I'm just taking out the number, I'm just need only the numerical data set. As more I'm going up, I am eliminating the textual data, I'm making sure the only the numerical data will be passed to my algorithm. Next is one hot encoding. What is a one hot encoding? First of all, let me guys show you what is one hot encoding. If you see this column, we have a high school or below, bachelor, college. Stay, again, I will go for the same explanation. If you pass the textual data set, your model will be not able to pick this data set. So you have to make sure this textual data should be converted to some kind of encoding. You should encode this data set. So how we can encode this data set? We are going to apply a one hot encoding. What hot encoding is a process in which you convert your categorical features into a numerical feature, into a discrete numerical feature, either 0, 1. So if you see this, I had a column in which the education of the person was bachelor. So instead of having a one column of education, I have created three more columns: bachelor, high school or below, or college. So if the person having a high school or below education, so it will be one, and rest of the columns will be zero. So now my model will be understanding, okay, so this column is one, so it means the education is this. Okay, now I will see the bachelor is, the education of this person is bachelor, so this column is one. I will see the education of this person is college, so this column is one, and rest of the values are zero. So your, it is not a textual data, now it is only a numerical data. So there, the data is now compressed into more compressed form. So now you can easily use this data set. So your algorithm can also learn from this data set. And I will not go ahead. Let's go for a small Q&A session. If you guys have any question till now, you can ask me. Then we'll go ahead for the next step, because next step is a feature selection. So just let's just take a 10 minutes Q&A session. You guys can ask any kind of question till from starting till now. If you have any kind of confusion, any kind of query, just feel free to ask me. So I will be answering your question. So guys, ask me any kind of question if you have. If you don't understand any kind of step, if you want me to repeat anything, do let me know. If anything new to you, you can ask me.
Guys, if you have any question, you can raise your hand or you can unmute your mic and you can ask a question. So I think there is no question. We can go ahead.
Okay, this then is no question, we can go ahead. Okay, so once we prepare our data set, we have done our pre-processing. Now next step is feature extraction, feature selection. It's not necessary you are thinking this column is useful, is going according to your sense. You have to be here the data oriented and model oriented person. Is my model needed this column? Is my model, is this my algorithm, is this my feature is redundant to algorithm or not? So we are going to check, is this kind of feature I can pick for my data by my model training or not? So this is called feature selection. Here we are just going to, we have a loan status. Again, we have a loan status paid off and collection. We are also going to convert this loan status to a numerical. So from categorical to a numerical. If it is a paid off, means it is settled, the loan is paid back, we have recovered this loan, it's going to be a 0. If it is still has to be collected, we're going to make it 1. So we have a discrete values. So we are just converting here the values. Once we got this data, we are going to perform the normalization. What is a normalization? If you see this data, it has different range. This column has a range from 100 to 1000. This column has range from this column has range from 0 to 100. This column also has from 0 to 100. This column has range from 0 to 1. This column has range from maybe 1 to 6. So all of the columns have range, different ranging. When you pass this kind of data set, your model has a chances to get biased toward the higher values. Means your model will be focusing on the higher values and will be not giving focus on to the rest of the small values. But we have all the values are equal for our model. All the values should be equal for our model. We want our model should focus on each of the variable, not only the single variable. So to eliminate this issue, your model should not get biased to any specific value of a variable. We are going to apply a normalization. So once you apply a normalization, it doesn't matter what is the range of these values. All the values will be having a similar range. Let's say your all the values will having a maybe range from 0 to 1, minus 1 to 1. So it depends on what kind of normalization you apply. Maybe apply standardization, any kind of other technique you apply. So it depends what kind of technique you apply. So after applying this technique, model will be not get biased toward any specific value. It will be giving paying attention to all the columns equally. So once we are applied the transformation, we applied the standard scaling. You can see here all the values in a similar range. So all the values are coming in a similar range. So none of your value are coming in different range. So that's the benefit of applying normalization. So your all the data set will be treated equally. Now you don't need to worry about is my model going to pay attention to this specific variable or not. So your now model will be giving attention to all the variables equally. So we are going to import some functions, Jacquard score, F1 score, log loss, Crosswell score. These are the functions which we are going to calculate the performance of our algorithm. So we are splitting the data set into training and testing. We are just splitting our data set. We are just separating our dependent and independent variables. We are going to state our dependent variable on the X variable, and on the Y train, we are going to store our independent variable, which is the target variable, which is the loan status. It is a paid or not. So we are just separating it. Now, what kind of algorithm we are going to? We are first going to implement the KNN neighbor. So what is a KNN neighbor? KNN neighbor is a supervised machine learning algorithm. It is a very simple machine learning algorithm. It assumes a similarity between two data samples and just compare just based on the similarities. It classifies the data set into a specific class. KNN algorithm store all the values available data set and classify a new data point. What it does, it do, it takes all the data set into the memory, and when a new data set comes, when any new data points comes into in front of a model, it compares the that new data point with both classes with all the data set and sees what's the similarity between the data points. Any point, any class is similar to that data point, that data point will be classified into that class. So that does KNN work. KNN algorithm can be used for regression and as well for the classification, but mainly it is used for the classification task because it works well on the classification task. It is also called a lazy learner algorithm because it does not learn from the training instead immediately. Instead, it stores the dataset, and at the time of classification, it performs an action on the dataset. Yes, this algorithm is called lazy learner because it just keeps the dataset into its memory. So it is not very memory efficient algorithm because when you create your machine learning model, maybe you have a very complex data set. So your data is complex, and if you make a very complex model, and obviously you're going to have an issue with memory management. So this algorithm is cannot work very well if you have a bigger data set. It can work well if you have a smaller data set. You can easily work on that. But as the data set grows, maybe it fails to give you a very good performance. KNN algorithm at the training store the data. When just store the data set into the memory. When a new data gets, it calculates the data into that category that is much similar to the new data. Suppose we have an image of a creature that looks similar to a cat and a dog. So this is how KNN works. So this is a pictorial representation how KNN works. But we want to know, we have an input image, but we want to know, is this new creature cat or dog? So what does KNN do? KNN has kept in memory the features of the dog and so the features of the cat. So it take the input image and check the feature of this input creature with the cat as well as with the dog. Those features whose has highest similarity will be classified into that class. So suppose the features of the cat is more similar to this input, so it's going to be in that class. So the all the time it perform the similarities. Based on the similarity, it basically perform your classification. So it keeps the features of the input data set into the memory, and when any new data sample comes and you ask them what species it is, it will check and simply perform your classification. So this is how KNN works. Why do we need a KNN algorithm? Suppose you have a two categories, category A and category B, and we have a new data point x1. So this data point will lie in which of these categories. You have two data classes and you have a new data point. You want to classify a new data point into any of these two classes, but you are not sure in which class you should assign this to which class you should assign him. So to solve this type of problem, we need a KNN algorithm. With the help of KNN, we can easily identify the category or class of a particular data set. Consider the following below diagram. So before KNN, we have a category A and category B. A new data point come. Okay, so but after applying a KNN, what we can do, new data point assigned to the category 1, because if we see this is more near to this class. So based on the similarities and based on the distances, it says you can assign this class to this new data point. How does KNN work? Let's go and see. First of all, KNN select the key number of neighbors. When a new data point come, it will check how many neighbors are near to this data point, how many neighbors from this class near to this data point. So if you see here, three neighbors are near to this data point and two neighbors near to this data point. So that class which has the highest number of neighbors near to that sample, that data point will be classified into that class. That's how nearest neighbor work. It basically calculates the distance of the neighbors. It checks my distance with this neighbor is high, my distance with this neighbor is very high, and also with this high. So I am going to classify into this class, but my distance is with not that much distance with only two neighbors. But here I am close to three neighbors. In this class, I am close to two neighbors. So I am going to classify into my this class instead of this class category B. So this is how it basically the class which has the high maximum number of neighbors near to him, it will be classified into this. So you this is how your KNN work. It basically calculate the difference based on the Euclidean distance. If you see this new data point and these three neighbors near to new data point, two neighbors. So as you can see here, three neighbors are higher as compared to two. So it's going to classify into that class. So you will be having the output as a class A, and this new data point will be pointed into the class A. How to? But now the question is, how many neighbors we have to compare? Maybe 10, 15, 20, 30, 40. We don't know. We have to find out optimal number of KNN which we have to compare. So to find out the optimal, how many neighbors we have to consider. Maybe if I consider five neighbors, so how many five neighbors? Five neighbors from this class, five neighbors from this class. If I am close to three neighbors, okay, I'm close to one neighbor, so I'm going to classify into this class. But if I have to consider how many number of neighbors, that is not sure. So this is a problem which you can identify by using different techniques. We have different techniques to find out how many neighbors we have to consider. So there is an algorithm which is called elbow method, which basically helps you to find out how many number of neighbors you have to consider. Advantages of KNN algorithm: it is simple to implement, it is robust to noisy training dataset. It can be more effective if dataset is large. It can be not well if your dataset is small. Disadvantages: always need to determine the k values. You always have to find out how many k values I have to consider. The computational cost is high. As I already mentioned in the above, the computation cost is high because it compares the difference at the each time whenever a new data sample comes, and it keeps the training dataset into the memory. So you may not have a very good prediction time. Maybe it will be not a very good response from your KNN algorithm when you try to predict it. So you can have a disadvantages of a memory storage. So now we are going to perform our KNN. We are going to find out how many number of Ks we have to consider for each class. So first of all, we are just going to training our K nearest neighbor. We are just applying a elbow method. Elbow method is basically a method in which to train your K nearest neighbor against different number of Ks. Let's say you train your algorithm for 1, 2, 3, 4, 5, 6 till 10, and after training your algorithm, you see if I when I pick the number of neighbors 6, I was getting a high accuracy. So you checked for each number of neighbors and you're getting accuracy on that neighbor is high, in that number of cases high, so you will use that. So if you see this, I train a KNN on from 3 to 11, and I saw my CV accuracy, my accuracy on the number of neighbors 8 is high. So I am going to consider the 8 neighbors for both classes. So I am going to pick the value of k neighbors as 8, so I can use this to my algorithm. So what I did, I just simply train my neural net, I might train my algorithm of Kn in nearest neighbor, and I'm calculating the Kn and Jaccard score, Kn and Fn score. Fn score is good, but Jaccard score is not very well, which is 25%, and Fn score is 75%. So we're going to talk about this Fn score later. Let's complete this implementation. So we got this result. So which is not very good. The accuracy is 75%, still okay, but not very well. Let's go and see how we can train another algorithm. So next algorithm is, we have trained our first algorithm. We're going to, in the last, to evaluate all these three models. We're going to see what are the prediction of these models. First, let's go to the implementation of this model, then we're going to talk about it. Next, second is decision tree. What is a decision tree? Decision tree is a very popular machine learning algorithm. It is a supervised machine learning algorithm which can use for classification as well as for a regression task. This tree is also called as CART, C-A-R-T, which means classification and regression tree. It is a versatile algorithm that can be used for classification and regression tasks. The main idea behind decision tree is to divide the data into the smaller subset. What does it do? It basically split your data set into smaller chunk, and each chunk it basically make a comparison, make a decision at each smaller tree, and making a decision and making a series of questions at each node. And once your series of questions are done, it basically combine and check what does is the output. So how does a decision tree work? Selecting the best feature, the algorithm stays at selecting the best feature for the dataset. To split the dataset, it does by evaluating the feature that provide the best split, which leads the most affecting separation of class or reduction in a variance of variance. Basically, split your, it creates a tree and split the dataset into two phases, and again split. It keeps splitting until your dataset does not get it divided into the single number of rows. Split, once you find out the which feature I need to split the dataset, it basically create different decision tree, and based on creating a different decision tree, it make a decision on each node. After creating a decision on each node, it basically combine the nodes decision and make a single prediction. So simply decision tree start by splitting your data into nodes and nodes and nodes, and once your nodes are done, it basically perform your prediction, and once the prediction is performed, it basically combine those prediction and give you a output result. Advantages of decision tree: simple to understand, it is not very that much difficult and interpret. Trees can be visualized and easily explained to and not an expert. Yes, when you create a decision tree, you can also create or visualize your tree of your data set, so you can easily understand how my model is making a decision. Can handle both numerical and categorical data. This is not the capability of all the algorithm. KNN cannot handle a categorical data, but the CNC can handle a categorical data. Some algorithms can understand categorical data. Some algorithms are very basic to categorical data. So that's the capability machine learning. This decision tree algorithm can handle easily the categorical data set. KNN has an issue with the outliers, but if you have a decision tree, it can handle missing values and outliers. So if you have a missing values and outliers in your data set, decision tree can easily work. Sometimes it's not necessary your algorithm, your data set is a very linear. Your data set can be a linear, non-linear. It can have a many hidden parameters, many hidden patterns. So you have to identify those patterns. So if you have that much algorithm which can identify those patterns, so you can easily work with that. So decision tree has a capability to handle and captures the non-linear relationship. robust to noise, and can handle irrelevant features. Yes, if you have irrelevant feature, if you have a noise, if you have any misleading values in your data set, you can easily use the decision tree that can work well. What's the main issue? Wherever you will go, they all talk about the decision tree is high prone to overfitting. What is the overfitting means? You train your machine learning algorithm. Let me give you example of overfitting with a real life example. So it always stays on your mind, because this overfitting question, if you are applying for a machine learning engineer job, they go always going to ask what is the overfitting and underfitting. So let me explain you with a simple example, so it always stays in your mind, so you'll never forget, because this approach can be quite tricky. So overfitting means, let's say you are a person who is preparing for an exam. You have a 1 year and you have a book. You have to read the book. What you are doing from the day start, you have 100 days. You have 100 days. You have 100 pages of book. You have decided, okay, I am going to prepare my, and you know your question. You have 100 pages of book from, but your exam is going to be unseen. But yes, they have told you your exam will be similar to that data set, that questions which you have in these 100 pages. You're saying, okay, if I learn very well, if I spend my 1 day on each page, so I 100 days, so I can learn all these things for the 100 days, in 100 days, so I can work very well in an exam. So but you started learning, you started spending your time, you started with day one, you completed 1 page, and day two, so on, and that's the 100 day, and you completed 100 pages. So you have learned each and everything from that book. Now you know each word from that book. Now you are in an exam. Now examiner give you a question paper, and now you don't know, the question is unseen, and you are also blank. You don't know how to answer this question, because you just learned from that data set, and now because you just memorized it, you did not went into understand the concept of those topics. So now you are overfitting, because you work very well, you learned very well from your 100 pages book, but as a new unseen question came, you are not able to perform very well. So that is called overfitting, means you have put your all the attention, your model is working very well on the training data set, your model has learned very well on the training data set, but not able to work well on your testing data set. So that's the overfitting. So you're not able to generalize on the unseen data set, especially if a tree is deep and not prone properly, so you can have overfitting. So that you can keep in mind. So overfitting happened, and when overfitting happened, maybe they also ask what is a bias and variance. So when overfitting happened, there is a variance in your algorithm. Variance means the predicted and the actual values has a very high difference. So variance is basically a difference between predicted and high values, predicted and the difference between your actual values. So if you have a high predicted difference between predicted and actual values, you have a very high variance. So that can lead to a problem. So the CN tree has a this issue with the overfitting. Can create complex tree that might not generalize well on the new data set. Yes, it can create complex tree, but sometimes might not generalize your data set. Small variation in data can lead a different tree structure. Yes, if your data change, if the variation change, you have to change your whole tree structure. Greedy nature. Greedy nature of splitting can lead to sub-optional solution. Maybe greedy nature means it does not explore all the options. If you are learn about the algorithms, we have studied the subject of algorithm analysis of algorithm. Maybe you know what is a greedy nature. Greedy nature in which your algorithm does not check all the possible state. It just find out whatever things the optimal for the algorithm, but that may or may not be the optimal for the algorithm, but algorithm thinks that may be the optimal. So that's the greedy nature. But may, maybe if your algorithm can work well because of the greedy nature, but may be not. So that's cannot be answerable. Decision tree is powerful algorithm that can be a valuable tool in your machine learning toolkit. By carefully tuning hyperparameter and parameter and considering pruning techniques, you can create a decision tree that are robust, accurate, and well suited for your specific task. Yes, you can do, but if you do care about all these advantages, you can work very well. So I'm just creating a decision tree classifier, passing my training data set and predicting. I'm just calculating the checkered and F1 score that is much better than as compared to the F1 score is very good as compared to the KNN. and a Jakarta score is also very well. So that's a very good learning from the training data set. So decision tree is performing very well. Next is support vector machine. Support vector machine, what is this is again a supervised learning algorithm. So you can just keep in your mind one thing: if you're new to machine learning, if you're performing a classification task, it's always a supervised learning algorithm can do. If you're performing a regression task, it's always a supervised learning algorithm can do. So that's the key point to keep and remember: is the algorithm supervised or not? Supervised machine learning it is widely used in machine learning algorithm that falls under the category of supervised machine learning. SVM is primarily used for classification tasks and also be used for regression. But it is not that much famous for regression tasks because of its capability. It can work very greatly with the classification task because it has a capability to create that decision boundary which can simply classify your data samples into two classes. So if you have a non-linear data set, you might algorithm other algorithms are not working very well. You're not able to distinguish between two classes. You're not able to classify your data sample into two classes. SVM can easily work. It has a very complex nature which can easily go with the non-linear data set and get your results done. The key idea behind the SVM is to find the hyperplane that separate different classes in the data set. The best hyperparameter is that one that maximize the margin between classes, where the margin is the distance between the hyperplane and the nearest data points of each class. So it basically create a line which basically separate the data points of two classes from each other, and that class which has the highest maximum difference, that's called best parameter. How does SVM work? SVM basically find out the hyperplane which simply maximize the distance between two classes. Let's say this is a distance of class A with class 2 that is trying to maximize the distance of class 2. Support vectors are basically getting separated based on the hyperplane, and just simply it create a decision boundary. That decision boundary is just simply maximizing the difference of two classes, and the SVM is performing its classification. Rest of the thing is same like decision tree, but I'm just going towards the disadvantages of SVM algorithm. Effective, just that's the main thing which you want to know. Effective, how it is effective as compared to other algorithm. It is can easily work in high dimensional spaces. What is high dimensional spaces? Sometimes we have a data set here in we have created it is a 2D algorithm. It is a 2D graph. Sometimes your data maybe is not always in a 2D. It may be in a sometimes your data is not easily to get differentiate in a two dimensional classes in two-dimensional space. So what SVM can do, SVM has a capability which add, let's say if your data is not able to classify into 2D space, SVM can add another space. It can make your data as a 3D space, and once you add another dimension, your data will become easily differentiable. So that has a very versatile nature of the SVM, which can just simply make another dimensional space, which can just simply split your data set into the different classes. Versatile and can handle linear and non-linear. It is famous for handling the non-linear data set because it has a kernel function, which kernel function allow him to create any number of high dimensional spaces. It can also go for 3D and also go for the 4D and 5D. It can number and handle any number of spaces. Work well with small and medium-sized data that can handle binary and multi-class classification. Binary means we are predicting here what is the loan rate. Is it a paid or still we have to collect. Multi-class means yes, just like black, blue. You have trained your algorithm by passing different colors of pictures, and you're going to predict what color is this. So it is a multi-class classification. Disadvantages, it requires careful tuning of hyperparameters. Yes, tuning a hyperparameters of SVM is not an easy task. You have to tune those parameters very efficiently so you can have a better performance. Can be computationally expensive. Yes, it is expensive. When you have a large data set, it requires a lot of time to converge on the global optima and to get a right decision boundary which can maximize the difference between two classes. May not perform very well on the noisy data. Yes, it cannot perform very well with the noisy data set. So SVM is a powerful algorithm that has proven to be effective in range of classification tasks by choosing the appropriate kernel function and optimizing hyperparameters. You can create SVM model that provide accurate and reliable prediction for your specific problem. So in short, SVM is a very good algorithm. It has a capability to simply separate your data points easily if your data is non-linear, if your data is non-easily differentiable. So we are going to create a sport vector classification because it is a classification task. So we are calling a sport vector classification. We are passing our training data, testing data. Once we have trained our algorithm, we are just evaluating our model based on the Jaccard score and F1 score. So once we get this, it is the Jaccard score and F1 score of the SVM is less than as compared to the decision tree. For the three algorithm, the decision tree is the winning tree algorithm which has giving a high accuracy. Last is the logistic regression. Logistic regression, its name is telling us a regression, but this algorithm is a classification algorithm. It is a supervised so you basically create it as a it creates a line which separates your two classes. That line is called sigmoid, that has a sigmoid function which basically differentiate your two classes from each other. Based on that differentiation, it gives you a probability. Let's say you have a probability, it gives you a probability from 0 to 1. Let's say if you have a class probability of 0 to 7, you have a probability 0.7. It means that's the probability is very belong to class 1. And you have a probability 0.3, so it means that the probable they define a threshold. The threshold is 0.5. Below the threshold the class will be 0, and above the threshold the class will be 1. So let's say you're performing a classification in which this person, the loan is going to be paid or not. If you are saying if the threshold is above 0.5, the loan will be paid off. If the classification will be the threshold is less than 0.5, the loan will be not paid back. So if that, let's say you run your logistic regression, you got the output as a 0.4, so it means the loan will be not paid back. So this is giving you output in the form of probability. So it gives you a probability value by calculating different kind of creating a decision tree using a sigmoid function. So you can just simply get your decision done. So if a probability class 1, it is 1, otherwise it predicts a class to 0. So this will simply perform the classification on your data set. Advantage is simple and easy to understand, efficient and computationally less expensive. Power is required as compared to other complex model. Provides interpretable probabilities. Classification can handle linearly separatable data as well as non-linear data with appropriate feature engineering adaptation. Yes, you can easily linearly separate the data set. Disadvantage is limited to binary classification. It can work very well on the binary classification, but if you increase the number of classes to predict, it may show up not very well result. So you may end up having a false prediction. So it is good for binary classification. If you have a binary classification task, you can consider it, but as the number of classes increase, you have to predict, it may not work very well. Assume a linear relationship. Yes, it assumes there is a linear relationship between the target and the predicted value. So it cannot handle the non-linear relationship. So we can not assume our non-linear relationship. Logistic regression is a fundamental algorithm in the field of machine learning as widely used for binary classification tasks, especially when interpretability and simplicity are essential. So it means if your algorithm is not that much complex, you can simply use this this classification algorithm. It serves as an essential building block for more complex model and is often used for the benchmark to evaluate the performance of other algorithms. Yes, it considered as a benchmark to perform the to calculate the performance of other algorithms. So let's go and see without wasting our time because we also have to do a lot of things remaining. So let's go and see the implementation. We are calling a function of logistic regression from sklearn. We are creating our logistic regression model. We are going to create a multinomial model. We are passing our data set. And once we train passing our data set, we are just making a prediction, which is going over, and we are just calculating the log rate, the Jaccard score and the F1 score. If you see this, that is the Jaccard score is low as compared to rest of the algorithm because of its simplicity of that algorithm, but F1 score is just okay. So now let's go and see once we have trained all our four algorithm. Now what we are going to do, we are going to load the testing data set. We have passed the training data set. Now we have to evaluate the performance of our algorithm on the testing data set. That's the real performance. The real performance of your algorithm is judged on the testing data set. So we are going to, the testing data set is similar to the real data set, but that is unseen data for the model. So your model will be checking, your model will be evaluating on this data set. So we are loading this data set. We have a two file, loan test and loan train. I will provide you after this webinar, so you can also run on this. So we have a loan status, same columns we have in this, but the number of rows are less than as compared to the training data set. So we are just performing the same things which we did above. We are converting to the date, the effective date. We are extracting the day of week, weekend, gender. We are using only this principal term: age, gender, weekend, day of week. We are just going to concat. We are going to perform the one hot encoding. We are going to convert the paid off and collection to 0 and 1, so we can have a numerical value. We have, after performing all the pre-processing step, we are going to see the Jacquard score, the F1 score on the test data set. Let's see how it performs on our data. But before going ahead into the testing, we are going to see what are the F1 score and Jacquard similarity score. It is also known as a Jacquard index or Jacquard coefficient. It is a measure of the similarity between two sets. In the context of classification evaluation, it is used to measure the similarity between the predicted set of labels and the true set of labels. In our data set, we have a target label and also the predicted value. So we are going to check our model predicted this, but the real value of the data set was this. So what is the difference between the predicted value and the real actual value? So it basically calculates how far your model is being performing on your testing data set. And F1 score, as we have a data, is imbalanced. So your made up, maybe if you use the accuracy, maybe you won't be able to get a good maybe not available get good evaluation using accuracy. So if you use a F1 score to evaluate the performance of your data model, because your data set is imbalanced, so you can get a better result, you can get a better idea. So F1 score is used to basically when you have a imbalanced data set and you want to calculate the performance of your model, then you can easily use to deal with this kind of issue. So these are the two parameters of evaluation we are using here. So we are first calculating the, we are just created a dictionary here in which we are going to store the results of all the evaluation parameters. So we are passing the testing data set to our KNN model, and we are going to calculate the Jacquard score, F1 score for test, for all these things. And if we see this, apart from compare as compared to the other model, tree is performing really well. F1 score is high on the testing. No, this is the training score. The training score was 0.92 and the testing score is 0.76. Yes, because testing is the test data set is the unseen data set, and your model is may always have a less test score as compared to the training score. So your, yes, it will be low. But if you see the logistic regression is same, is almost same. It was 0.14 and 0.74. It is same for both of the training samples. So, and also if we talk about the KNN, it's also around similar. So we have calculated the parameters of the evaluation parameter metrics of our model. So we are going to basically ask from a user. Now we have trained our model. Now my model is ready to make a prediction from for our user. So our user is a person who works in a bank. He has to perform his analysis. This person is a right person to give a loan or not. So we are going to ask him. You can run this code and you can enter the number of the parameters to our model, and our model will give you output. Is this person is a right person to give him a loan or not? So we're going to ask him, give is the principal amount he's asking, for how many time, for how many number of days, he's asking age, gender, weekend, is asking on a weekend or is asking on weekdays, what is his education, all these things we are going to ask him. And once we're taking this input, we are just going to convert the, if education is high school, we're going to make it one. If this, we're going to make it one. So we are just going to change the values. So we are just going and pre-processing the values, and we are just, once we have done, we are also applying the pre-processing on our input data set, because we have to pass the pre-processed data set to our model. Once we done this, we are just passing that input feature to our all the 4 trained models, and we are just comparing the output of our model. So if our model say 0, it will pay back, and if not 0, it will not pay back. So we are just going to calculate based on the I enter the number of the principal amount is 1,000, number of installment is 30, his age was 25, gender was female, yes, it was weekend, his education was bachelor. So I am getting the output from my different machine learning algorithms. So my KNN say this person will pay back. Okay. My decision tree prediction says will not pay back. Okay. My SVM is still saying will pay back. My logistic regression saying it will pay back. But as we have seen, the decision tree was performing very well. So maybe you can use the prediction of the decision tree. So he will not pay back because she's asking also on the weekend, as that we have seen most of the people who are from bachelor, they are not easy to pay back the loan. So see, we are making a prediction at the time of the, now we are giving a chance a user to interact with system, and he can make decision based on the data. Now he has don't need to worry about the making calculation and doing all this time manually. He can just go and enter this the input into his model, and the rest of the job will be done by model. The calculation, the decision will be done by the model, and he will be just getting a output. Is this a person ready, right person to give him a loan or not? So our model will say no, will not pay back, so we'll not give him the loan. So this can help the person, the credit analyst, the person who is sitting in a bank is trying to assess this person is a right for the loan or not. So it can help him to make a decision, and he can just do, okay, my model is saying not give him a loan, my model is saying give him a loan, so let's give him a loan. My model is saying no, he will not pay back, so we will not give him back. So instead of having a lot of work, manual work, he can just automate this work using a machine learning algorithm. So that is the one of the application we have seen, we have implemented from A to Z. We took a data set, we have a data set which has a raw data set, we took out the meaningful information, we tortured the data, we take out a lot of meaningful information, we pre-process the data, we applied the feature selection. Once we perform the feature selection, we perform different machine learning algorithm. After creating different machine learning algorithm, we made a prediction from our model. If you have similar data, if you have a working in a similar domain, you can take this data, you can just relate these things, you can just create your model, and you can make a prediction to aid your business. So this is how machine learning can help you to aid your business, where you can just simply make your decision more better and more faster, where human takes time to make a decision. So now you are getting more time to do something else. You don't have to review your application. You can just pass to your model, and it will be making a prediction. So that was it for today. In short, let me summarize what we have seen. We have seen 4 different models, how we can create, what are the benefits, what are the disadvantages, how they can help us to make a decision. We have seen the So if you guys have any question, you can please ask.
Anyone want to ask question, please raise your hand.
I think no one have any question.
I think there is no questions. Babu Mark, please.
Please go ahead with your question. You are lagging. Can you please text your question in the chat? Actually, I can't. Actually, I can't hear you clearly.
Leave your question in chat box, please. I think, sir, there is no question.
Okay, so we can
Now,
end our
now, now
webinar.
we are going. Now we are going to end this session. Now we are going to end the session. In the end, thanks to sir to give us valuable time.
You're welcome, and thank you everyone for joining my session. It was a nice learning.
Thank you so much for sir for your valuable time and all participants who joined. You can be with us after
this module. There will be a module 3 on deep learning. So guys, stay connected with our social media handles, Quest Innovative and Study Circle. So see you, Allah Hafiz.